Okay. Hi, everybody. My name is Steve Wilson. I'm from Constellation Research. Constellation is a small specialist independent technology research firm, technology analyst firm. We're based in Silicon Valley. We are independent. We research AI, robotics, cloud, enterprise technology, collectively disruptive tech. And we try and provide our buy-side customers as well as our vendors insights into the things that matter over the medium term. We deal with early adopters and fast followers as categories of clients. I'm based in Sydney, but I've got a global role looking at identity, privacy technologies, cryptography, and therefore blockchain. David Marchant came across my work a couple of months ago and thought that given that cryptocurrency and ICOs are beginning to become important in your world, he would like me to come and give a primer on blockchain technology. And he gave me this provocative title about the Kool-Aid because he knows my work and he knows that I'm probably one of the independent voices in the world of blockchain. I have an unpopular view that blockchain is not what it's cracked up to be. My experience is that almost everything that you read about blockchain is wrong. My considered view after looking at this for about 6 years is that blockchain doesn't do what people think it does, and therefore it's unlikely to change the world in the way that people assume that it will. What I want to do today is to provide a bit of a primer about what blockchain does, what it does not do, what it was for, and to help people understand what it's probably not for. Where does it fit, where does it not fit? There's a tremendous amount of work still to be done. It's still early. The blockchain is younger than the iPhone, which tells you, I think, a bit of perspective about how long we've got to go. Blockchain is absolutely going to make a difference in some areas of financial services. It will continue to make a difference in terms of ICOs and cryptocurrency. I think that it's a very bad fit for most of the enterprise things that we're talking about, and I want to explain that as we go today. So above all, I think this session is all about helping you tune your bullshit detectors because you need to keep your critical thinking on. The claims that are made for this technology and the assumptions that are made about its power are prima facie wrong, and I think it's really important for investigators to understand that. So thanks. Let's make this reasonably interactive. I think we've got a bit more than an hour to go. If you just let me talk, I'll talk for an hour. But we can stop as we go. So when did all this start? I forget when the iPhone exactly came out, but I remember vividly when blockchain came out. It came out with an obscure paper written by person or persons unknown, Satoshi Nakamoto. I would recommend anybody read this paper. It's only 10 pages long. It gets heavy going halfway through. It's a heady mix of cryptography and pure maths and politics and economics and banking theory, currency theory. It's a really heady read, and you can certainly get halfway through it. You absolutely must read the executive summary because that sets the scene, and it's amazing how many things are done with ICOs by people who have clearly not even read the executive summary of the Bitcoin paper. It's pretty dry, though, for something that's supposed to have unlimited sociological import. The subject matter is dry. It's the problem of double spend. And the abstract, the second sentence of the abstract says that this paper is all about preventing double spend. Double spend, as we'll see, is a problem that's been around in cryptocurrency for 30 years ahead of the Bitcoin paper, and it was solved. It was solved in the 1980s by a guy called David Chom. Nakamoto came out of nowhere and solved the double spend problem in a new way, and I want to spend a bit of time talking about that today so that people understand. Again, I think that you'll get a long way by understanding what blockchain is for and what style of problem was it trying to solve, what style of solution pattern does blockchain exhibit, and then that'll help you understand, I think, what its fundamental limitations are, and therefore try and become a bit more immune to the Kool-Aid. So have a look at the paper. Now, I try and get away without analogies and without metaphors because, again, we get stuck in wrong thinking and misconceptions because our metaphors are so crude. The one metaphor for blockchain which I think really works is the Wright brothers flyer, the classic disruptive tech, the classic problem that couldn't be solved until those guys put together their contraption with paper and bicycle wheels and string, and they flew, and it was amazing. But what did it mean? Just like blockchain, everyone and their dog, within a year of the Wright brothers' flyer, got into their garages with their bits of string and bicycle pumps and engines, and the first generation of flyers after the Wright brothers were preposterous. And it only requires, it can only be done with hindsight to look back and work out which ones of these Heath Robinson contraptions were actually sensible or not. So I don't know whether there are aviation buffs in the audience or not. Have a look at that website, it is fascinating. Two of those contraptions are super significant. The one at the top right was the first plane to go across the English Channel, about 8 years after the Wright brothers. The one at the bottom left was the prototype fighter plane. So remember, within about 12 years of the flyer, we were bombing people in the First World War with this technology. So it did change the world. The other two contraptions, they just lived and died. Nobody ever knew what came with them. They were nuts. And most blockchain applications are in this category right now, but it's too early to tell which ones are going to fly and which ones aren't. Has blockchain changed the world or not? It's certainly changed the publication world. There are hundreds of people out there that have rebuilt their careers on books, preposterous books. Some of these things are crazy. I've got one of these books. Every page is seriously wrong, and it's one of the best sellers. Every page, I'm not exaggerating, contains really serious errors about what blockchain's all about. I think David Marchant set the scene. I think he described blockchain as a bit of a boxing promotion and mentioned some of the hyperbolic claims that are made. So let's have a look at some of these. Let's survey some of these things. It's been said that blockchain will crowdsource the policing of the monetary system, period. As we'll see, Bitcoin is a very special, very niche electronic cash. It's not a credit instrument. You're not going to upsell a financial product from a bank using Bitcoin. Bitcoin is absolutely not any part of the financial system or the money system. It is an electronic coin. So the idea that you would take blockchain and use this as the basis to change the financial system itself, especially the governance of the financial system, I just don't know where this idea comes from. And then, of course, people get way outside of the financial system and they think that because blockchain has this ability to do consensus and it's got something to do with truth and trust or something, there's lots of magic words around blockchain. So people assume that it's going to do things like stamp out corruption in Africa. Enough said. Much more recently, in the Australian Parliament, an Australian senator convened the Parliamentary Friends of Blockchain, and she said that this technology has got the potential to change the public service because we won't have separate departmental databases anymore. We'll have one database. We won't need thousands of public servants doing whatever public servants do. Public servants don't do a lot of database admin. Public servants do a lot of work off the chain in the real world, talking to real people about their real problems and creating data for sure that needs to be stored in much better ways. But blockchain is not a database, and it's not going to get rid of those thousands of people that are out there in the real world establishing what the real truth is. Blockchain doesn't do that. So it's preposterous that people, especially in powerful parliamentary positions, can get the wrong end of the stick like that. And finally, somebody who, if anybody should know better, this guy should, Vitalik Buterin, invented Ethereum, the second blockchain, probably the most important blockchain. And Vitalik, he's a boy genius. The guy was about 20 years old when he invented Ethereum. He actually wanted to do 3 different PhDs. He wanted to come up with a new algorithm. He wanted to invent a new programming language, whatever. But I don't think that he's ever had the rigour for any school to pick him up as a PhD candidate. So instead he goes out there and does this stuff. And then every year or so he comes up with some new ideas about governance. If anybody tracks Vitalik's maturation, he is reinventing the wheel all the time and thinking he's awfully clever for remembering things like governance or remembering things like software testing. Well, at one point he said that blockchain is going to compete with Uber, as if blockchain is an app, as if blockchain is an actual platform where you can not only order an Uber, but you can complain when the Uber doesn't turn up, or you can rate the driver, or you can get your money back, or you can exercise a dispute. Blockchain doesn't do any of that. It's a really clever piece of maths. And for people like Buterin to go out there and to start exaggerating the magic properties of blockchain, to me it's absolutely breathtaking. And like I said, if we can spend an hour and get our bullshit detectors tuned up, then I feel as though I might have done my job. So seriously, WTF. There was a question in the previous session about why do people put their money into cryptocurrency when we all know that if something looks too good to be true, it probably is too good to be true. I think that there is Bitcoin exceptionalism occurring. I think that people have gone through the internet and the dot-com boom and the tech wreck, but they still think that this is going to be different. And I think it's just like Arthur C. Clarke said, that sufficiently advanced technologies look like magic, and then we just suspend disbelief and we go with the flow. There's a mob mentality behind Bitcoin. There are some special things that Bitcoin does. It did solve what the cryptographers will tell you was an unsolvable problem. And when the orthodoxy, when the institute, when the academy says that something's impossible, like you can't fly, and somebody does that, then that is a seriously important moment in science and engineering and technology, and it happens every now and again. And it happened with blockchain. Blockchain did solve one particular unsolvable problem, the double spend. But beyond that, because blockchain was imbued with magic talk, words like trust and trustless, and consensus is my other favourite word, because it's imbued with these words, some of those writers that I talked about before actually think that blockchain itself will change democracy and get rid of corruption in Africa. So, to help you understand why that's not the case, for 10 minutes I'm going to talk about what blockchain does and what it doesn't do. Now, normally, and I'm sure everybody's done a blockchain talk or suffered through one, and at this stage you're going to be holding your breath because I'm going to talk to you about hash algorithms and solving puzzles and what else? Merkle's trees. I think you have to know about Merkle's trees, and we're going to do a cryptography course right now. We're going to lecture you about public keys and private keys. No, we're not. It's not necessary to know how blockchain works. It's only necessary, I think, at this level to know what it does and why it does it. And we can leave, blockchain 201, blockchain 301 to another day. So double spend is really easy to understand. Electronic cash is ones and zeros. Ones and zeros are held in hard drives and computer memory, and they get copied. And you can't tell the difference between original ones and zeros and copied ones and zeros. So if the concept of digital money is that you've got some sort of memory, you've got these little orange memories, and they hold cryptographic money, and you're going to move money from one person to another. At some point, evil Alice is going to spend her money twice. She's going to send the same ones and zeros copied to two different recipients. That's double spend. How do you stop it? You stop it by watching every single transaction. Every single movement of digital money gets watched and recorded, and somebody has a look for that double spend, and they pick it out, and they call it out, and they stop it. Now, there have been architectural patents for this for a very long time. Like I said, in the 1980s, the paradigmatic electronic cash was something called DigiCash by David Chom. And DigiCash involved what Chom called a mint, a digital mint, a bit like the central, a bit like any central monetary system reserve bank. So the purpose of the mint was to be a central repository for all of those transactions. It would watch every single electronic cash transaction, DigiCash transaction, and look out for the double spend, and then adjudicate about which one came first. Now, the Nakamoto paper was an express rejection of central administration. It's political. It's completely political. And I don't take a political position about this. I think reasonable people can disagree about whether or not reserve banking is a good thing or a bad thing, or whether Visa and MasterCard are forces of evil. You can disagree about these things, but let's just understand what the politics was. The politics was, let's do away with any central bank and let's crowdsource the supervision of double spend. So it's crowd currency. Now, the way it works is through a consensus algorithm. Now, again, consensus, it sounds like magic talk. It sounds like what we mean in English about agreement. It's actually not. Consensus is a mathematical technicality. There's a whole bunch of consensus algorithms out there. They've been around for 20 years. There's one called Raft that is core to Google search. So look up any pure maths textbook. Usually post-grad, this stuff gets pretty arcane. But the science of consensus algorithms has been with us for a long time. Nakamoto did several really interesting things and put together some core technologies in a new and innovative way, and we can argue about whether Nakamoto was a bowerbird who picked and put things together, or whether Nakamoto was a real genius or not. certainly, Nakamoto did something that was very smart and put together some building blocks. So one of them was consensus, and a consensus algorithm in Nakamoto's world runs on a distributed network of computers, and that network of computers grows over time, and it's the nodes of those computers that reach consensus about the state of the data. Now, the state of the data is periodically updated in terms of what's called blocks, and the blocks are strung together over time, and the blockchain is literally that series of decisions that the crowd has made about all of those monetary transactions. And it's as simple as this. For every transaction, you need to know which one came first. And if two identical transactions came from the same wallet at about the same time, the crowd decides which one they saw first. And they say that the first one is real and the second one was a double spend. Another clever thing that Nakamoto did, of course, was that they invented mining. And mining is the idea of rewarding those nodes for their work. It's called proof of work. That's the technical name for the algorithm. The work is done, computer cycles are spun, people are rewarded randomly every 10 minutes or so with a little bit of Bitcoin. It's worth reminding ourselves, I think, that the original assumption was that there are so many spare computers sitting around the world. Has anybody done those crowdsourcing projects? I think there was a search for extraterrestrial intelligence 20 years ago that used PCs. You could download a little bit of software and you could run a little bit of code on your computer, and at night it would churn away processing radio telescope signals. And every now and again something interesting would be found. It's essentially pulling together the internet as a supercomputer and using the spare resource to do something useful. That was the spirit of blockchain. The spirit of mining was, how do you get thousands and thousands of computers to work and cooperate, and how do you incentivize people to do that? And one of the genius things that Nakamoto did was to say, let's give them literally a Bitcoin reward. So Bitcoin is manufactured by this process, which is why the metaphor of mining is used. So that's blockchain. Why it does what it does? It expressly rejected central banking, expressly rejected authority, and said we're going to crowdsource the supervision of an old problem, which is double spend. How do you make sure that people aren't double spending? Now, it was magic. That the unsolvable problem was, how do you stop double spend without that central mint? And that's the problem that was solved. But because A, it did that in a clever way, B, it was using magic words like consensus and trust, very, very quickly people thought, look, if there is this public utility out there called the blockchain, and it's acting as an immutable ledger of history, it's a record, why don't we do other things with it? The software that runs the Bitcoin nodes is open source software. It's maintained by a volunteer group. It's got APIs, and the APIs have got slots where you can throw auxiliary data into a Bitcoin entry. So you can run a dummy Bitcoin transaction, and at the same time you can stick some more data into that transaction. So the little red stripe there is just my cartoon of saying, here's a little bit of dummy data, extra data that I'm going to pop into a Bitcoin transaction. And that dummy data can be a token for anything you like. And so if the idea is that Alice has a block of land, and Alice wants to sell that block of land to Bob, Alice does a Bitcoin transaction from Alice to Bob, and she sticks a representation of her land title into that ledger, and that becomes the record. It becomes the transfer record of title. That's the idea of putting land titles on the blockchain. Same idea about putting diamonds on the blockchain. A startup company, I want to say 6 years ago, called Everledger, started by a very clever Australian woman who realised that precious diamonds around the world for a very long time, to manage blood diamonds and conflict diamonds, for a very long time by agreement, there's been a standard barcode that's etched by laser into the base of any diamond, I think over 3 carats. It's not my world, 3 carat diamonds. My wife wishes that it was, but it's not. I understand that these barcodes are unique by agreement. Through De Beers or whatever the hell's going on, the diamond industry has reached agreement on how to code the unique diamond codes. And the idea of Everledger as a business was to use the blockchain to store those barcodes. And so when a dirty big diamond is barcoded and laser etched, you take the number and you stick that into a Bitcoin entry and you launch that onto the blockchain. And that is the way of managing the provenance and the transfer of titles of diamonds around the world. A couple of problems with that, which we'll come back to later in the talk, but certainly Everledger was a really interesting case. People have been putting marriages on the blockchain. I think it actually happened in Las Vegas literally 5 years ago. People are trying to put health records on the blockchain. People are trying to put sneakers on the blockchain. This was literally a company called Chronicled raised $1.3 million in New York 3 years ago because their use case was collectible sneakers. Again, this is not my world. I mean, 3-carat diamonds I wish I had. $300 gym shoes, I don't wish I had. But there is a market for $300 gym shoes, and as soon as anybody's crazy enough to spend that much money on a shoe, then they're liable to buy a fake $300 gym shoe. And so, I don't want to trivialise the counterfeiting of clothing and the counterfeiting of luxury goods. I don't trivialise that. It's an important problem. But the way that Chronicle solved that was to get an RFID tag in the factory that represents the genuine gym shoe, and then you take that RFID code and stick that onto the blockchain, and hey presto, you can transfer the ownership of the gym boot. And that solves provenance. Well, it doesn't solve provenance because the character in the factory who's stapling the RFID tags into the genuine shoes or the fake shoes, you've got to trust that character. So as soon as you've got anybody in the real world, here they are, the character in blue who's saying this is a real gym shoe, this is the blockchain entry, that's the single point of failure. And Satoshi Nakamoto is rolling in his or her grave right now at the stupidity of taking a real world thing and representing it in the blockchain, because the blockchain was supposed to get rid of single points of failure. It was supposed to get rid of people and bad actors. There are no actors in the blockchain. So as soon as you get the blockchain married to the real world, and I talk about the analog to digital conversion, when you go from analog to digital, when you go from real world to blockchain, you have to take extreme care with what's happening off-chain. And you need to pick your use cases really carefully. You need to look at the best uses of blockchain for things that are purely digital and are always digital and never have that sort of fakeable or corruptible connection to the real world. And Nakamoto, like I said so him or herself in the second line of the paper. They said that if you have a trusted third party in your use case, then the benefit of the blockchain is lost. So why don't we summarise what the Generation 1 blockchain was all about? It's permissionless, another one of those weird sort of crypto words, but permissionless means that there is no gate. There's no gatekeeper that stops you from getting your Bitcoin in the first place, or from downloading Bitcoin mining software and being a miner and contributing to the community. And permissionless is a good thing. It's like a rejection of KYC. It's certainly a rejection of authority. It's also an important property of blockchain because this thing needs scale. You need thousands and thousands of computers in the blockchain network or it winds up incorruptible. And so permissionless, like a lack of friction, a lack of entry, is an important thing in order for blockchain to reach that critical mass. Now, I'm deliberately using some shutter quotes in some of these properties. Anonymous is something that needs to be put in shutter quotes. Anonymous, it's anonymous insofar as nobody knows who owns a Bitcoin wallet, because there is no KYC and it's permissionless. Anybody can go out there tomorrow and get themselves a Bitcoin wallet. So it's anonymous insofar as nobody knows the real owner of the wallet. But one of the quirks of blockchain is that every single transaction is uniquely and immutably and permanently identified by the public key of the wallet holder. And this is what happened to Ross Ulbricht, the guy that was prosecuted for running the Silk Road. Had kind of forgotten, as smart as he was, and as much as he covered his tracks using onion routing and Tor browsers and PGP and everything, he forgot that every single transaction that he ever made was uniquely tied to a pseudonymous code. And once the FBI, through some very clever malware of their own, tied his computer and his IP address to that Bitcoin address, he was gone. So anonymous in quotes. It's pseudonymous for the privacy people. Immutable, also in quotes. You know, I've been in security for 25 years. I've done a lot of requirements analysis. I do a lot of risk assessment. And people absolutely want databases that are tamper resistant. They want records that are digitally signed so they are tamper resistant or tamper proof. People want permanence. People want stability in their data. But this word immutable, until blockchain came along, I'd never actually heard the word immutable. And I think, you know, people were sitting around going, what's a really powerful word for permanent? Oh, immutable. I had never heard of immutable as a requirement. I think that immutability is a creature of blockchain. I think it's a word that was not in the security parlance until the paper came along. Immutability is important to the blockchain because the only record you've got of every one of those transactions is the blockchain. And if the blockchain itself was to become tampered with or corrupted, then the game's over. So yes, it needs to be very, 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 very tamper resistant. Whether or not that's truly immutable or not is a keen debating point. I won't go into the detail, but every now and again these public blockchains get forked, which is an interesting pun. When you fork a blockchain, the transactions are no longer immutable. Every transaction in a particular branch of that tree is superseded and wiped out, and you start again. So even the diehards, even the people that believe this stuff in all of their hearts, you back them into a corner and they will walk away from words like immutable as well. It's decentralised. Now, in computing, decentralisation is important because it's got to do with resilience, and the internet itself, was a Defence Department project in the 1960s and 70s to build a network that was resilient against nuclear attack. And so decentralising networks is part of computer science. It's very important, and blockchain does that, but it doesn't do it for any old computing application. Blockchain decentralises the supervision of the crypto system. Nakamoto was clearly a very good architect, and they set out with some initial assumptions, and the initial assumption was solve double spend without a central mint. And if you're an engineer and you're given that task, that assignment, then you go away and solve it, and they did. If you came along and said, I want you to decentralise health records, I think the architect would come back to you and say, that's not the sort of, health records aren't quite the same as cryptocurrency, so let's talk about it. And I make that point, and I underline that point twice, because you don't get decentralisation from blockchain. You get blockchain from decentralisation. And not all use cases can be decentralised. Blockchain's highly available. One of its underrated properties is that it's always there. The APIs are always there. It never goes down. You can always get the data. It's like the permanent database in the sky for very special uses. And finally, it's trustless. Is it trusted or is it not trusted? And a lot of people choke on trustless, and I'm going to come back to that in a minute. To summarise, blockchain was designed for Bitcoin, and it wasn't really designed for anything else. And therefore, it's really hard to generalise. If you take something like a solar-powered car, in Australia every year the students get together and they have a competition to run a purely solar-powered car from Alice Springs to Sydney, which is about 2,000 miles. And these are fantastic machines, and they go like the clappers. They go 100 miles an hour across the highways with one lightweight passenger who's usually like a jockey who weighs about 90 pounds dripping wet. And they're in Lycra, and this thing is stripped down, and they're very uncomfortable for about a day and a half, and they race to Sydney. And that's because that very special purpose technology was designed to get you from A to B with solar power. If you came back and said, I want to generalise that machine and I want to tow my boat on that car, or I want to put another passenger in the back because it's really uncomfortable, or I want to run this thing on a dirt road and change the suspension, all of your design team would go back to basics and say, oh, okay, what are we going to do to have a solar-powered SUV? That's a different proposition. So I make the point about generalising. You don't generalise a really special purpose technology just for the hell of it. You have to go back to the drawing board. And not enough people have gone back to the drawing board with the public blockchain in order to make it fit these other use cases. Now, one of the really silliest things that was ever written about blockchain was the front page of The Economist. Is the date on there? I want to say it was 4 years ago. The trust machine. And, it's only a headline. So maybe I'm taking this too seriously, but I don't think so. I think that this word trust is a powerful word. It's a magic word. We know what it means face to face. Scammers, God, did you hear the stuff about boiling rooms this morning? I mean, those scammers know about trust, and they know how to make total strangers trust them. So I don't discount trust for a minute, but I do say that trust is a human thing that you get out of, getting inside people's minds and being magical. You don't get trust out of ones and zeros. You do not get trust out of this algorithm. Now, trustless is a word. In security, trustless is a word. And I want to take you back to classic security. I think anybody who's talked about security for a minute has heard this idea about the tripod of security. 3 factors make up anything that's secure. You need some good technology, you need some good people, and you need some good processes. So banking, lots of cryptography, lots of hardware security modules, lots of EMB chips, lots of tech. Banking, though, lots of audit, lots of standards, lots of process, lots of regulations, lots of training. So banking is that classic thing where the tripod is easily understood, that to get secure banking, you can have the best technology in the world, but if your tellers are corrupt or if your bank manager is on the take. So, obviously, 3 things make up security. Until blockchain came along. Because there's one thing that blockchain does, and it does it with the tech only. It takes the people in the process out. And as a security guy, I'm here to tell you that this is really special. And, you know, I get goosebumps about this. It probably doesn't make anybody else particularly excited. But trust me, if you can make a secure system, if you can promise that Bitcoin is going to get from Alice to Bob without any people or processes in the way, that is magic. And that's exactly what Bitcoin does. Does that make it a trust machine? It makes it the opposite of a trust machine. Alice and Bob need to know nothing about each other at all, and that money is going to flow. So for the economists to call this a trust machine is a really serious category error. And I think that it's important to dwell on that fact. I don't think I'm just playing semantic games here. I think for this idea, this trope to have survived for so long that the Bitcoin and the blockchain is about trust is a very serious mistake, and it has led to I don't know how many dead ends. But all is not lost, all is not doom and gloom. This thing has evolved, just like the Wright brothers flyer evolved into Airbus A380s in about 100 years, which is incredible. So too is the ledger evolving. Let's try and unpack a few sort of myths and misconceptions though. Blockchain, Bitcoin, distributed ledger, cryptocurrency. Are these 2 things different or not? And in the last day and a half, I've had a number of really cool conversations over coffee about, okay, Bitcoin's a bit silly, but wow, that blockchain's going to change the world. Well, maybe not. Yes, blockchain and Bitcoin are different. Yes, the cryptocurrency can be decoupled from the ledger in exactly the same way that a train track and a locomotive are technically different. But these 2 things are so symbiotic. A locomotive without the train tracks is useless, and the train tracks do nothing without trains. So the idea that the blockchain as a train track is something that you can do other things with is only technically true. It is not true broadly. And even if it was, even if you thought, I can take anything at all, I can take an aircraft carrier and I can run that on a railroad track by putting a bogey underneath it. A lot of blockchain applications are exactly like that. A lot of them bend over backwards to do something on the blockchain that should never have been done on the blockchain in the first place. So again, critical thinking. So in a nutshell, I want to talk about what the next generation distributed ledgers are doing. And I want to give you some words that will hopefully allow you to have more conversations with people as you get into this in more detail. Unlike Bitcoin, people and process in these new generation applications are absolutely inherent. And so these are not trustless systems anymore. And the examples, I'm going to give you lots of examples, but there are complicated financial instruments now, share swaps, multi-party contracts, stock market settlement, other financial instruments are being done on special purpose private ledgers, but these are not trustless systems, and people and process are absolutely inherent in what's being done with these systems. And so that leads to different architectures. These systems are administered. They are distributed, yes, but they tend to be concentrated. So the Bitcoin blockchain has about 8,000 nodes, 8,000 miners at any one time. And yes, I know that some of those miners are concentrated, so in effect some people say there's only 7 miners left because of the consortiums, but technically the Bitcoin network runs on thousands and thousands of nodes. Some of these new blockchains, such as the Hyperledger Fabric instance that's running in IBM, runs on just 6 nodes. And this makes the purists' heads explode. I've seen purists sit in IBM conferences going, what? You've got the entire blockchain running on a mainframe, an IBM mainframe? Like it's doing my head in. It's the absolute opposite of the blockchain utopia. Now, you can get into all sorts of arguments about that, but I think it's important that we see that the religion of super distributed blockchain is giving way in some applications to much more concentrated systems. Now that means also that you're then moving from these volunteer community free and open source models into more of a managed service model, which is what happened with cloud. So cloud technology, in a sense, history is repeating itself. And finally, while the security promise of blockchain is based on thousands and thousands of computers in a trustless manner, all communicating and watching every spend and agreeing that they haven't seen a double spend, conventional information security applies to these new models. So they become concentrated, they run in data centers, they run on big, fat hardware security modules. Some of these blockchain services like Oracle's and Salesforce's, they actually advertise and they leverage the fact that their people are highly trained, they're security cleared, they've got top secret vetting, etc. So again, Nakamoto would be rolling in their grave because all of this is starting to look like really conventional tech. Conventional data centers running mainframe computers, but, and I'm very happy to sort of concede this as a blockchain critic, they are doing something different. They are doing multiple transactions across parties that are at arm's length. And so instead of having total strangers operating without an administrator, what you have is applications like interbank settlement happening between banks at arm's length. So they're reducing the level of admin, but it's still there. So what do they actually look like? The actual distributed ledger technologies, complex financial instruments, share trading settlement, Australian Stock Exchange. Trade documentation, so purely digital trade documentation, meaning that the cargo manifest that goes with the container as a ship travels across the world. So let's spend 1 minute about this because it's an amazing use case. A cargo manifest on a container that's holding avocados, for example, that have been, what's the classic? Avocados in Nigeria are sent onto a pallet. They're boxed up, they're shipped off, they're driven to the port, they go onto the container, the ship sails to Singapore, they unpack, the boxes get taken off, the box winds up at a freight forwarder, they take the bubble wrap off and there's no avocados in there. And they go, what the, so they go back and they have to look at a fax and then there's an email and there's somebody wrote down on the delivery truck's, windshield, that there was a breakdown, there was a flat tyre in Nigeria and those avocados never made it to the port. And that usually takes about 10 days or 3 weeks to work out and it costs money. Now, here's a figure to reckon with. IBM and Maersk calculate that the average time to resolve that type of shipping dispute is 60 days. And time is money. They reckon that 5% of the cost of shipping is caught up in those sorts of dispute resolutions. 5% of the cost of shipping. The cost of diesel for the world's shipping fleet is 5% of the cost of shipping. So if you could use better information technology to make that dispute resolution quicker, you can literally save as much money as if you just did away with the diesel fuel. It is an amazing, eye-watering business case. And that's what IBM has been working on for some time. So that's the trade documentation idea. Digitise things, get them onto a distributed ledger, do it at arm's length so you don't have all of these intermediaries getting in the way, creating friction, and you wind up with data which is very, very accurate from the moment that it hits the blockchain. And that's the idea behind trade documentation. So that's a little use case for you. I think in your world, it's important to understand that because it shapes the sorts of good applications that are coming out. Now, what does that mean for fraud and investigation? It's still about the endpoints. The character in Nigeria who's shipping the avocados, or the character who's cutting the diamond and saying this is a 3-carat diamond. Actually, this is a 3-carat conflict diamond that my mate sold me out of an illegal mine. But I promise that I'm going to put the barcode on it. The weakest link in these things is still the human being. And so the import of all of this stuff for investigation and for the fraud community is that it does not do anything to get rid of the human being. It certainly provides better evidence, faster evidence, fewer intermediaries, and maybe therefore fewer touch points for fraud, but you still need to have your antenna on about where the weak links are. What else have we got? Supply chain comes up over and over and over again, supply chain is a killer app for the blockchain, and a special case of supply chain is pharmaceutical serialization. So that company that I was rude about with the luxury sneakers, that company has reinvented itself, and it's still called Chronicle, but it's working on pharmaceutical serialization, and that's a very important use case, and the people in charge now, I think, are doing some really good work. Now, what's left to be done? There's still a lot of heavy lifting, and I think there's some things that may never take off. So the things that you'll hear a lot about that are still unproven in my estimation are identity, identity in shutter quotes. Some of the best identity blockchains out there, they're very, very early. They don't even use the word identity anymore. They're talking about personal data in this new medium. Government records. So, the Australian senator who said that every single government record is going to wind up in a single database. Well, I don't think so. That hasn't happened yet. I was talking to a guy just this morning about the Swedish experiment with land titles in Sweden, and the Swedish government has abandoned that project after 2 years because government records are put together by government people, and it's not the type of environment where you're just going to get rid of people and go trustless. Voting, I think, is probably the worst example of blockchain that I know of. For the following reason, remember that blockchain is all about anonymity, and it's all about no admin. And when a blockchain really works well, you've got total strangers out there working these cryptographic magic keys in their mobile phones, exchanging Bitcoin or Ethereum. Great. What about voting? Voting, one person, one vote. In cryptography, it's one person, one private key, one vote. And there's nothing in any blockchain that guarantees that one person has got one private key, because blockchain is the opposite of that. Blockchain magically makes money move from one wallet to another without anybody controlling the wallet. True magic. You can't vote with that sort of technology. It's the opposite. It's the wrong problem. So, with that sort of little moral of the story, hopefully you can see what makes sense and what doesn't make sense. And finally, Internet of Things. Every day, literally, I'll get a press release about an IoT. In fact, there is a special blockchain called IOTA, which is being done for the IoT. And the idea there is that things, cars, should be exchanging data about themselves and about their drivers, and the drivers should be rewarded. There should be micropayments for all of this stuff happening. It's quite a utopian sort of hippie framing of the attribute economy that we're all going to be paid. Instead of giving all of our data for free to Google, overnight, Google's going to, I don't know, see the error of their ways and stop being a $100 billion company, and instead people are going to get paid a fraction of a cent for their car reporting to the insurance company that I haven't had a crash yet. And the IOTA blockchain is going to be the way of protecting that data and giving me a micropayment. Not in my lifetime. Google is not quaking in its boots about this sort of thing. Google Maps is going to continue to work because it gets all of the data from your mobile phone. The reason why Internet of Things is problematic is that devices are not like cryptographic wallets. Devices are hard devices. They've got serial numbers. AT&T knows where I am right now, or Google does. These devices are not like free-floating Bitcoin wallets. They are hard devices with private keys. They're registered. They're serial numbered. They are pre-registered. They don't need blockchain. And so I think I am very cynical about almost every IoT use case that I hear. Now, a hell of a lot of hard work is being done in niche areas that are very, very important. So 99% perspiration, right, according to Thomas Edison. Blockchain came out of nowhere 10 years ago, but since then, people like R3, it's a consortium of very big banks based in New York, have been working on blockchain-related algorithms for very special purpose and very specific multi-bank arm's-length transactions. And, I use long sentences to describe this stuff deliberately and a little bit rhetorically to say that, it's not easy. It's not like electronic cash. If you talk to the people at R3 about what they're doing, they write lengthy papers to explain what they're doing because Wall Street is complicated. And the multi-party contracts that are done, the big, derivative swaps that are done between 5 different banks, these are complicated things. And nobody understands them. but R3 is doing some really good work. So I would recommend, there's a white paper called Corda, C-O-R-D-A, written by a guy called Richard Brown at R3 about 3 years ago. Really good work that explains why the confidentiality and anonymity and ruthless transparency of blockchain does not work on Wall Street. And it's a really good paper that said this is the properties of blockchain that we need to reimagine and do differently. And there's a number of other ones there. We'll make this slide deck available to you to have a look at later on. But we'll call out, the Sovereign Foundation does a lot of work in identity management. Hyperledger Fabric, built out of the Linux Foundation, does a whole lot of really good standardization in this area. JP Morgan, now we're getting close to home, and we'll talk about Quorum and the infamous JP Morgan coin in a minute. IBM TradeLens is the shipping manifest solution that they've got going with Maersk, and Microsoft is doing some very good work, but it's very niche work. So I want to conclude this presentation in the next 10 minutes by having a look at how worlds are colliding between payments and blockchain technology and the things that David asked me to sort of look out for. What's it called? Coin360, this is one of the best websites for tracking minute by minute the price fluctuations across almost every one of those, 2,300 coins. You watch this go up and down and there's a ticker tape. And again, the cryptocurrency purists should look at this and reject it, because why does it matter how much US dollars your Bitcoin is worth? Why does that matter? If you are an electronic currency purist and you want to buy stuff with that electronic currency, you have deliberately left Wall Street behind. You've left the Reserve Bank behind. You've left the greenback behind. So for people to be obsessing about this, the people that obsess about this are the speculators. This means nothing to anybody that actually wants to buy stuff with Bitcoin, or it shouldn't. And of course, the amount of Bitcoin that flows for actual purchases, so somebody earlier said that you can buy stuff, you can buy Tesla, you can buy Safeway, you can buy Microsoft stuff with Bitcoin. I don't think that's true. I think that Microsoft last year stopped accepting Bitcoin. So there's another one of those fluctuations. So yes, you can buy stuff with Bitcoin, but apparently the total proportion of Bitcoin movement that goes to buying stuff is about 5%. And the rest of it is money going in and out of the exchanges on speculation. Now, tokenization is a super important thing to understand. Tokenization, sadly, is a word that's got about 5 different meanings across security and financial services. In the blockchain world, what tokenize means is to take a real-world asset and represent it and stick a digital code onto a ledger somewhere. So Everledger, the diamond thing I was telling you about, is classic tokenization. Much, much more recently, JP Morgan coin, the infamous JPM coin that was announced about 6 weeks ago. This is $1 US represented digitally on the JP Morgan Quorum blockchain. Now, why would you do that? You would do that because normally when you're moving cash between cash accounts, it can be done relatively quickly, but it's always reconciled and there's always an audit process and people need to literally balance the books. The idea of a blockchain here is that you can pre-balance the books, you can pre-audit, because the process of reaching consensus in a couple of minutes will tell everybody in the network that money really moved. And in theory, there should be no need to audit the movements of JPM coins. Now, you heard that from me. I have not heard that claim being made by JP Morgan themselves. I think that would be a bridge too far. But the idea is eventually that this sort of settlement would be done and it won't need an audit. And then, of course, you can see how a lot of money will be saved through that sort of carving out of the traditional overhead that goes with financial services. But all of these things involve off-chain trust, and I just want to really hammer that point. You need to have people and processes that are occurring in the real world off the chain that you can trust. And JP Morgan would make no bones about that. The R3 consortium makes no bones about the fact that their Corda system is highly administered and it's got real people behind it. It's unlike Bitcoin. So there are single points of failure in these systems, and therefore you need to have really good people. And finally, I want to just leave you with a thought about consensus, that idea in Bitcoin that we're going to reach consensus about the state of the ledger, because when Alice moves a Bitcoin to Bob, you need 8,000 people to all look at that. In fact, just like that funny BBC video that we saw in the previous session, The whole world is looking at every single transaction and saying, yep, we agree that that's what happened. So that's what consensus is. But, you know, when you've got a JP Morgan coin moving, and JP Morgan themselves has said, here's a US dollar and we're going to represent it as a token, what consensus is there? Why would you get 8,000 nodes around the world to have a look at that and agree to it when JP Morgan, you have to take their word for it? So it's really ironic to me that the Bitcoin and blockchain evangelists will say, we're going to use this technology to strip out all of the overhead of audit, but all we're going to do is replace it with the overhead of 8,000 computers grinding away, or even 5 computers running in an IBM mainframe in the cloud. There's an enormous amount of computing overhead that's going to create this thing called consensus, to reach consensus about something that you don't need to agree about because it was a fact that a JP Morgan coin moved. So be really careful with consensus. Be really, really careful with crypto exchanges. So, you know, there's 100 of these, but the famous ones in my mind to review are Mt. Gox. Arguably the first big crypto exchange went belly up, 4 years ago, partly out of corruption. Nobody's really sure, but it looks as though the people running Mt. Gox actually took the keys and took the money. But another part of Mt. Gox's problem was that they were hacked, and an external hacker found the private keys and exercised the private keys and moved a lot of money out. In 2 tranches, if I remember right, there was like an $18 million theft, and then there was something like a $300 million theft that just wiped them out. Let's just review that for a minute. The keys that we're talking about, the private keys, these are cryptographic keys that are normally, in an ideal world, kept in a chip on your phone or in a smart card or a Trezor wallet or one of these things. When you look at payment systems around the world, they're moving more and more towards chip. You know, the SIM card, the EMV card, the Apple Pay secure element. The chip is an important thing, and the chip is supposed to hold your key. These exchanges often hold the keys in trust for people. And trust, there we are with that fantastic magic word again. Trust, hold my keys in trust at Mt. Gox. Mt. Gox was saying, we're going to take your precious US dollars and convert them into Bitcoin, but don't you worry about running your own wallet. It's too hard. We'll run the wallet for you in the cloud. So again, it's another one of those worlds colliding. It's like outsourced computing. It's like IBM or Hewlett-Packard all of a sudden doing Bitcoin for you, which is something that you were always supposed to do for yourself. The philosophy of Bitcoin is that you have to do it for yourself because you don't trust anybody. So what could go wrong? What went wrong was twofold. The Mt. Gox people were idiots. They didn't have proper security and their private keys were hacked, and they were crooks. And they saw the hackers coming and they thought, well, we're going to actually help ourselves to some of those private keys before it's too late. Much more recently, Quadriga in Canada. This is a great disaster recovery moral of the story. The founder and head of Quadriga unfortunately died, and there's some speculation that he might not have died. The real scam might be that the guy's still alive and faked his own death in India, but let's assume that he did die, and what happened was that his passwords died with him and access to the private keys. So, you know, somehow Quadriga was smarter than Mt. Gox because the private keys weren't just accessible to hackers, but they were dumber because the private keys were controlled by a password that one person had. Now, this is just, people will run around talking about governance and they'll really underscore governance. How about bloody common sense? What sort of business has that sole person risk, that critical person risk where, you know, there are plenty of safety deposit boxes around with passwords. I mean, show me a business where the password for the business is in the chief executive's head. So there is something exceptional about blockchain, something exceptional about how these things are run, where people just don't even think about that. And so that's what went wrong with Quadriga. And much, much, much more recently, as in yesterday, the news has finally come that the New York Attorney General is taking action against the notorious Bitfinex. So Bitfinex is another cryptocurrency exchange, and they tie their work up, or they backbone their work on a special crypto coin called Tether. Now, Tether is one of these tokenized, or it's called a stable coin. It's a cryptocurrency that's pegged to the US dollar. And the Bitfinex promise was that they have real currency float, a real backing, and it was something like 5 billion Tether, I think. Now, my maths is rusty, but if 1 Tether equals $1 US, then 5 billion Tether must be around about $5 billion, and nobody looked. You know, for a startup company, you'd think that $5 billion was pretty noticeable. Nobody looked. Nobody ever tested. Nobody ever questioned whether or not Bitfinex actually had that much money. And so now the New York Attorney General is looking. So this news came yesterday. Don't you love it when you're doing the last minute changes to your slides and you Google around a bit? And so somebody in the audience, I was talking to Sasha over lunch, people have been looking for this for months. This problem has been around for a long time, but the news has finally broken that the Attorney General is holding them accountable for this $850 million fraud. So that's nice. A timeless tweet from a guy about 5 years ago said that the funniest thing about Bitcoin is watching libertarians reinvent the financial system. And it's tragic comic. It's true. And if you watch Vitalik Buterin, every couple of months he'll say something breathtaking like, oh, wow, we should do code inspections. As if, you know, as if these things haven't been thought of before, as if we don't have 50 or 60 or 70 years of experience of how to run these things. So the libertarians are being held to account. There should be lots of these. There should be lots of sovereign electronic coins by now. And every now and again, countries have speculated, or it has been speculated about countries doing this. The classic one is Estonia. Estonia, kind of the most digital country in the world, has had a blockchain lab for about 5 years. They, in fact, invested in a blockchain company in Estonia that is still an early startup company. It hasn't done anything. But I talk to people that assume that you're voting in Estonia on the blockchain, and that Estonia has launched a crypto dollar of some sort. Well, they haven't. The best example so far is, in fact, the Bahamas, which only a month ago announced in a press release that they were going to create something called the Sand Dollar, Project Sand Dollar. It's a Bahamian cryptocurrency, and they've signed a contract with a technology company to try and make this happen. So this is really new. Somebody earlier said that Venezuela was going into crypto, but I mean, they could go into anything and nobody would really know if it was true or not. So very interesting to me that there haven't been that many actual government coins out there. And I think the reason is that the government monetary policy people and the money scientists and the computer scientists have probably got together and said, what are we going to reach consensus about? And if we have a reserve bank that is literally printing money, why would you reach any consensus about that? So there could be an argument that Bitcoin, and this is what the Bahamians are doing, they do want to use this technology to remove the friction and to streamline KYC processes. That's all really good, but you just have to be really precise about the problems that you're trying to solve before you start running around and saying that there's going to be the future of fiat money. And I think it has to be said that some of these announcements are nothing more than FOMO. You know, it's not your 14-year-old adolescent kids that get FOMO because, you know, you've taken their phone off them before they go to bed, or they're going to, oh, please, Dad, can I go to this party on Saturday night? The worst FOMO in the world, the captains of industry in Silicon Valley who say, I missed the internet, I'm not going to miss blockchain. And then there are whole governments that are saying, we're going to get into crypto because we're not going to miss out. You know, let's think about it a bit harder than that. So, how's this stuff maturing? It is maturing. It's going from prototype to proof of concept. It's like we're still in a bit of a homebrew. That's the idea of the imagery. We're still in a bit of a homebrew mode for blockchain and cryptocurrency, but some important work is being done. And as cynical as I am, and as much of a hard mark as I am, I absolutely salute the work that's been done by R3 and IBM and Microsoft, etc. What I say to them, and some of these companies are my clients, what I say to them is don't forget business process re-engineering. Don't forget the stuff that we said in the 1960s and the 1990s, and any project with tech, the biggest cost is not the tech, it's the business process change. And that's exactly the same with this project. Think about trade documentation. You know, IBM and Maersk, they've spent probably close to $1 billion already in the last few years building TradeLens, but they're going to spend a lot more money redoing the contracts. you're going to redo the fundamental contracts for shipping. And you don't do that lightly. You certainly don't get the junior to come in or the intern to just do a cut and paste on the contracts. This is hard stuff. When you change the way that business is done, which is the promise, then you have to change the way that risk is done. And that is really hard. The only company that I know that understands this properly is the Australian Stock Exchange. They are doing a 3-year contract, a 3-year project to re-engineer their trade settlement project, the trade settlement engine. It's a 30-year-old piece of tech. It's written in COBOL. And they are re-engineering with a lovely company called Digital Asset Trust using a new algorithm, private blockchain, very interesting. 3 years because they figured it's going to take them 2 years to redo the contracts with the trade brokers, with the share brokers, because this is new. So BPR. Watch out for the innovation versus the theatrics. You know, the theatrics of my collectible sneaker is on the blockchain and therefore it's secure. You know, that's just nonsense. We will, good and bad, cryptocurrency will continue to run in this parallel universe. Now, I hope that it stays in the parallel universe. I think that there is some really important stuff that cryptocurrency does. It is great for remittances. You know, I am as appalled as the next hippie about the 25%, 30%, 40% that a Bangladeshi home worker gets charged for wiring money back home. It's appalling. And if you can do that with cryptocurrency and disintermediate the money transfer people, fantastic. But that's like a parallel universe, and it has its fraud and its criminality that goes with that. But it's a parallel universe, and we should be disciplined about what blockchain is good for. And that type of thing of moving electronic cash is different from what it means to be doing trade settlements or financial swaps. And so the problems that R3 and JP Morgan are solving are different from the problems that Ethereum and Bitcoin are going to do in that world. And so that's me being charitable and being an architect. Like, we should have multiple blockchains. We should have blockchains for cryptocurrency. We should have more complicated ledgers for more complicated problems. But the other thing that has to be said, of course, is the Bitcoin cryptocurrency community really should be moved off onto a desert island because they're so ruthless and angry and difficult to deal with. They forget. You know, it's so funny. They're so angry. You should go to some of these meetings where they try and decide on the next software upgrade. My God, I mean, it's savage, literally savage, and political. And they forget that their mission is political. I mean, as clever as their hash algorithms and their Merkle trees are, and their zero-knowledge proofs, it's still a political mission. And if Nakamoto was given a different mission and said, why don't you do electronic money with an umpire, Nakamoto would have come up with something quite different. Key management, too technical. Okay, I want you to take away that Bitcoin is for strangers exchanging electronic cash. They don't know each other. They certainly don't want any third party getting in the way. It's no friction. Nobody's getting in the way. Nobody's censoring my money. That's what it was for. That's what it does. It does it with distinction. The second generation blockchains are actually fairly similar. They are about doing arm's length agreements on a ledger. And that ledger might not be having money on it. The ledger might be about shares or investment instruments or something that's still digital and virtual rather than electronic cash. But it is something that's digital. It's a ledger and the parties are at arm's length. That's what it does. That's what it's for. So all of the other stuff that goes with it in the popular press and in those potboiler books about trust and democracy and consensus is just nonsense. There is no truth in a blockchain. That term truth should be qualified and stuck in air quotes and used with great care. Because all it does is it works out which entry was done first. It doesn't do away with auditors as such. It certainly doesn't do away with lawyers. The idea that these smart contracts represent that code is law is just, it should never be let out of the gate. Yes, it's trustless in that sense that I said that security normally has 3 pieces, and if you take the people and process out, yes, it's trustless for these really rarefied use cases of like pure cryptocurrency. There is absolutely no way that you generalise consensus. So because the words consensus and voting and democracy are all part of the same word cloud, please be careful to not just assume that the mathematical consensus algorithm has got anything to do with consensus about what's going on in Washington. People have actually said that you could put the Congress on the blockchain and you could redo government decision-making in that way. I mean, I'm not even going to finish that sentence or the period. I'm not going to dignify it with any punctuation. And tokenization. So this is a technical point, but it's really important. As soon as you tokenize anything, you've introduced a single point of failure, you've introduced an administrator, you've introduced somebody who says, trust me, I've just barcoded that diamond, and it really is a 3-carat genuine non-blood diamond. That's a single point of failure introduced by tokenization. And so tokenization produces a bastard child. It produces a Frankenstein monster of the purity of the blockchain with off-chain trust and reliance. And so, proceed with caution whenever you see tokenization. Wow, what a negative sort of dickhead Steve Wilson is. I'm not. I'm just here to say it's only the beginning. Remember those 10 years of aeroplanes that followed the Wright brothers flyer? They were crazy. And I don't know what happened in the 1920s, but I bet a lot of people started saying this aviation thing's never going to happen. And maybe that's me. But I want to say that the Wright brothers flyer didn't directly change the world. What changed the world was the aviation industry and airports and trade and passports and everything that goes with it. And the difference between the Wright brothers flyer and what really changed the world, I think, is going to be like the difference between what we have today with blockchain and what's to come. So we are only at the beginning, and I hope that we can go into the future with our eyes wide open. Thank you. Happy to take some questions, or I think we've got a couple of minutes, or we can talk over coffee, which would be my preference at this stage. Thank you.